Now we'll be taking the derivative of part C. Since we're taking the derivative of the x variable, and x shows up both in the numerator and the denominator of a single fraction, we're going to have to use the quotient rule. So we need to remember the formula for the quotient rule of taking a derivative. If you have a function that can be thought of as a quotient, a numerator divided by a denominator, then the formula for the derivative is f prime times g, the derivative of the top times the original bottom, minus f times g prime, the original numerator times the derivative of the denominator, divided by the original denominator squared. So for our problem, the numerator, our f function, is e to the 3x, and the derivative is copy the question since it's exponential. Take the natural log of the base, although the base was an e and the natural log of e is just 1, so we don't need that. And the derivative of the top, which is 3. So we have 3e to the 3x for the derivative of our numerator, which will be the first part of our quotient rule. We'll go ahead and let g be the denominator, which is the binomial 1 plus 5x cubed, whose derivative is 15x squared. We're ready to take the derivative of the h function. So first we took f prime, which we'd already found to be 3e to the 3x. We need to multiply with g, which is the original denominator, the binomial 1 plus 5x cubed. Then we have minus in the formula, and we have f in its original form, so our original numerator of e to the 3x times g prime, which we've already found to be 15x squared. And this is all over the original denominator of g to the quantity squared. So as we look at this, we notice our red f prime term can be distributed. Sorry for the creaks. So we're going to need to clean that up. So what happens is at first when we distribute it to a 1, then we really just have the same item itself. Now we need to distribute it to the plus 5x cubed. So we're going to have the 3 times the 5 for 15. Since the x cubed, e to the 3x and the x cubed are not like terms, we tend to write the x cubed first. Now I wrote x squared, which is a typo, and I'm going to clean it up in a second, and the e to the 3x last. So now I have my minus sign, and there is no pluses or minuses between any of these terms that I just highlighted. So really we're just going to rearrange it where we have the numeric coefficient value first, any x terms second, and exponential terms last to give us minus 15x squared e to the 3x. And this is all correct over the original denominator squared. Nothing changed there. So now the thing is, if you look at this, each of the terms in the numerator begins with a lead coefficient, and all of those lead coefficients have a common factor. They all have a 3 in common, so we're going to be able to factor the numerator. So our derivative now needs to be, well, let's see, between these values, I already stated it's only a 3 we can factor out. The next term from the first term, the next part of the first term in the numerator is an e to the 3x, and we notice that showed up in all 3 terms of the numerator, so that can be factored out. Because we've looked at everything from the first term, everything before that first plus sign, and then we don't need to continue. I agree that even though there's some x's in the next 2 terms, since there's no x's in the first term, we're done finding our GCF, our greatest common factor. So we look at the first term, and if we're going to factor a 3, e to the 3x out of that, what is left? Well, just a 1, right? We want to be able to distribute that back and get that term, so we kind of need this 1 placeholder for that to happen. Now I look at, I'm going to factor, whoops, wrong color pen. I'm going to factor the 3 out of a 15. So that's going to leave me with a 5. And I need to factor the x cubed out, which is going to take all of it, but it does leave me that x squared term. Now remember, that x squared term is a typo. It should have been x cubed from the line I just highlighted. So So as I wrote the minus sign, and again looked at factoring a 3 out of the 15, which gives me a 5, and then as I went to go write the x squared, this is when it caught my eye. Wait a minute, why do I already have an x squared here, or whichever spot caught my eye? So I fixed these two x squareds to be an x cubed, like they originally should have been. Now I'm ready to keep going with my factoring. I've taken the 3 from the 15 to leave me a 5. There is no x squared to factor out, so it stays there, but the x cubed factors completely out, so I'm done factoring the numerator, and this is actually the answer to the question. I'm all done.